Okay, now I'm going to try out the use of the computation layers again, okay, using my samples. You can come to this page to find out the CL samples, okay. So in this page, okay, you can modify and edit by activities. So you can just click copy and edit, all right. Now remember, you have to log in as a teacher, all right, and then also try to go to Desmos Lab to turn on all the features, all right, in order to copy and edit my activities. Okay. Now once you make a copy, then you can start editing it or play around with the computational layer inside. Okay. There are several commands I would like to recommend, particularly. So the first one, for example, make use of a script and to capture the values that you input in the value. So if you preview it, it should be like this. Student may give a number to suggest the radius of the circle. Okay, so this is the input field. And the input value will be transferred to the graphing window at the same time to create another circle. Okay, so it is operating this way. So that is a graph component, and you have this equation. This one is shown. It's a black circle in the window. And another one is not displayed yet, okay? Because the values of k is not defined. Now, of course, you can define the values of k as you like, and then use it to change the color or the appearance, okay? You can modify it. But later on, the values of k will be replaced by the code, right, or by the numbers input by the student. So you can keep it here, but it is just a dummy. All right, so we go back to the script. Now this is the place where you can find the scripts, okay? And you can click open it, and then you can find that it's just one simple script saying that the number k inside the graph window is defined by the number from the input, the number input, okay, the numerical value. So if you want to find out more about all these code, you can click on this link to find out the page of computational layer documentation, which gives a very good summary, right, of different objects, okay, in the script. And for example, you can start with getting start here, and then find out sink and source. Let me see, not this one. Okay. Maybe at the beginning, yes, this one, that you can find out this example, okay. And here with the icon on the right, you can click on the other link to see the example directly. You can try it, okay? And this is an example offered by the Desmos. When you close it, when you close it, and you can see the script, okay? That means you can check where the script is put inside it, okay? This is an example of a slide. And if you click preview again, then you can simply copy the whole screen, copy the screen, okay? So you can press Command C in your keyboard, or depends on what keyboard you use. Okay, when you click it, then you can copy it. You can close this page. Okay, you can get back to this anytime you like. And then let me see. Yes, this is my example. Here, in any one of this line, you can paste it. I use the keyboard, okay, Control or Command V. Then you have now copied that screen to your activity, and you can freely examine the code and also try to study it carefully here. All right. Now remember, this script refer to the input value labeled as exponent 1, exp1, and which is corresponding to this input field here. This is the name of the input field. Right? So you can name it as you like. And if you click, change it to exp1a, for example, then the script will also be, should also be turned or corrected accordingly. So this will refer to the newly named input field. Right? So you extract the value from that input field to make a graph based on the M that you define there. Okay, go back to my example. So this explains how this script works. Okay, if you click on the input field here, then you will get the value K from the student's input. So that is the first simple example. I will show you how the value from one component can be extracted and then transferred to another component. Okay. All right. Now the next one, the following few slides no, this one basically I just create another circle and ask the student to guess the number, which will be put into this input field. I call it input tool. Okay, so the preview is like this. So the student can input any number as estimations of the radius of the circle. But this time the radius is not shown here. The circle is not shown here. Instead, this value is collected and then plotted in the next screen, right, as part of a graph, right, to display all the estimated value submitted by all students. Okay. Now, how it worked, you can see that this is the page for the circle and ask the student to guess. The next page, we have a graph. But the graph actually depends on the value from the input in the previous slide. Okay, so the script is like this. If you click on the script area, then you'll find that there are basically 3 lines. Okay, so the new, okay, now we have a new command, which is called the number list. And so it will generate a list of number based on the input from all students, not just one student, okay? So from the same input field, the numerical value will be aggregated. So we use this command aggregate to collect all the values from the students. Now, meanwhile, you can also see one number D, which is the input from that particular student on the screen. Right? So this is just a single number, okay, from one student. But the N is a list from all students. The lower one is about the bounds, okay? I may not explain the use of the bounds here, but it will help you to format the window in a better way. You can explore this one later, or go back to the Computation Layer document to find out how you use the bounds or make bounds. I think it should be here. Yes, the mix bounds command. Okay, go back to this window here. And so how the data can be displayed, right? Remember, the N is the list of numbers, okay, and aggregated. So a dot plot of N will be formed. At the same time, the D, the D value is the one submitted by one student, okay, and this one will be replaced by by that one in the script. Right? So for the time being, D is just a dummy, okay. Okay, and that is the reason why when you try to submit a value, okay, let's say, then in the next screen, you will see your number shown on the graph, okay, together with other numbers produced by other students, okay. So that is the way we can collect the values and then try to discuss with the students. And so the aggregates command can help you to extract all the value from the student. This can directly be used in a number of topics in statistics, obviously. But besides statistics, I think we can also use it in other kind of mathematical tasks as well. Okay. Now, so the following tasks will be more or less the same. The last one I would like to demonstrate today is the use of the ideas of capture, okay? Capturing the values from the graphing window. Okay. Now this time we need a action button, okay, to do the capturing of the value. Now what does it mean? If you look at this example, you'll find that the point C is a movable point in the graph. Okay. But once when you press the capture button, okay, then that particular position will be recorded, right, and then plotted on the screen at the same time. Now you can move the point C, but this value is will be stayed here, okay, until you capture another point, okay, then you have a new recorded value maintained on the screen. So you can keep doing it any number of times you like, okay. Now then we're going to find out how it works. All right. Now in this graph component, you can see that we have a basic value A and B as a movable point. Okay. So this is this part shows a movable point with the x coordinate, y coordinate. We call it as A and B. Okay. And so based on this recorded value in the action button, this part is the action button. You can find out the action button here component, right? and then you can edit. And the action button inside the script, you'll find that whenever you press the button, the values of A and values of B will be stored in another variable inside the action button, which called X and Y coordinate. So these are the names that you can give them. Okay, and then based on this coordinate from the capture button, you can go back to the graph window and check it out here. Now the XY coordinate will be another new variables in this graph window. We name it A reason and B reason. Simply means that this is the last recorded values, okay, in the capture button. At the same time, the history of the capture button will produce a list of values. So these are lists of A and B values, okay, based on what numbers you have captured so far. And so when you go back to the graph, we read the rest of the graph, then you will find that AB is a list, okay, AB list. This is a list of numbers. And when you have really submitted some numbers through the button, then you will generate a list, which will be plotted here as well. At the same time, the more recent one will be recorded as another point, okay, separately in here. Okay, the rest are just ways to add other elements in the graph. For example, I use a new polygon tool to draw the line segment, and also calculate the angle in the following way, okay, which can also be displayed here. And that's why in the graph here, you can see the angle value being displayed here. Okay, and you can have a look of other tasks which are used in the following way. Okay, so these are the major components or the scripts I would like to recommend. And so you can find it out from the computational layer for more details and more examples. And they are well organized here in this page. Okay, so far this is what I like to demonstrate. Okay.